All right, just to go back a little bit, recapping what I just said in the last video. So we've got probability of cars given males is 0.24, probability of males is 0.57. We're trying to find the probability of cars and males. So we plugged in 0.24 to the formula for cars given males. We plugged in 0.57 for the denominator of just the probability of males. And now we're trying to solve for car and male. We can cross multiply. I put 0.24 over 1. When we cross multiply here, we've got the probability of car and male equals 0.57 times 0.24. When you do 0.57 times 0.24, you get 0.1539. And so that is the probability of cars and males. All right. Number 7, probability of A is 0.71, probability of B is 0.2. What probability would confirm that these events are independent? So this goes back to what we said before, that for independent events, that means the probability of A times the probability of B is equal to the probability of A and B. So to confirm that they are, in fact, independent, that means that the probabilities, when they multiply together, needs to equal the probability of both of them happening. So the probability of A, 0.71, times the probability of B, 0.2, equals 0.142. So to verify it, we would need the probability of A and B to equal 0.142. And if it did, that would tell me that probability, or the events A and B are independent events. All right, number 8. Number 8 says find the probability that a random U.S. resident has traveled to Mexico, or the probability that a random U.S. resident has traveled to Mexico is 9%, to Canada is 18%, and to both is 4%. All right, here, what's going to be really helpful is to draw our own Venn diagram. So let's go ahead, and I'm going to make a box right down here. I didn't give myself too much space, so I'm just going to draw it here, and we've got Canada and Mexico. We'll say Canada here, Mexico here, just so we remember. And then, so we got to fill it in. The percentage that have been to Mexico are 9% total. This 9% includes the 4% that have been to both. So to find just the people who have gone to Mexico, we need to take 9% and subtract the 4% who have been to both. So only 5% of people have been to only Mexico. Now, for Canada, again, the same. Take the 18%, subtract 4%, and we get 14% have been to Canada. And lastly, the intersection, that is the people that have been to both. So that's where those 4 people go. Now, what about people who have not been to Canada or Mexico? Well, to find that, we need to subtract these percentages from, we're going to subtract them from 100. So we don't know how many people they surveyed. Doesn't say it's a survey. We're given percentages, so that's why we're going to subtract from 100. So 100 minus, we've got 14, minus 4, minus 5, and we're left with outside 77% have not been to either. All right, so A says find the probability that a random U.S. citizen has been to Canada but not Mexico. All right, well, the probability you've been to Canada but not Mexico is people only over here in Canada's little bubble. So people who have been to just Canada, that is 14%. And we could even do 14 over 100, 7 over 50. Again, just be familiar with the different ways that this could be written on an exam. You could have a decimal, you could have a percentage, you could have a fraction. They all tell me the same exact thing. All right, then find the probability that a random U.S. citizen has traveled to either Canada or Mexico. So this is everybody who has traveled to Canada, to Mexico, or to both. So let's go ahead and add all the people who have been to Canada, 14, plus the people who have been to both, so now we're at 18, plus the 5 people who have been to Mexico. So the probability that you have been to either is, all of those added is 23 out of 100, or 0.23, or 23%. Those are all the probabilities that you've been to either or both. All right, and then C says find the probability that this random U.S. citizen has not been to either country. So if we're doing the probability you've been to neither, well, we already found that when we filled out our Venn diagram. That was 77 people who said that they had never, or 77% had not been to either. So we can do 77 out of 100, or 0.77. And that would be the number, or the probability that you have been to neither country. All right. Moving on to 9, we've got our table here. First thing we're going to do with this table, let's just add up all of our totals to make it really simple on us later on. So we're going to add, first I'm going to start with the rows. So PE, we have 131 total. Fine arts is 93, 136 for technology, and 177 for foods. We have 95 ninth graders, 127 10th graders, 142 11th graders, and 173 seniors. And total then, we have surveyed 537 students. All right, so finding the probability first, the student likes PE. So probability of PE equals, well, how many students total liked PE? We'd have to add this whole row. We've already done it. 131 out of the total number surveyed would be 537. So there's the probability a student likes PE. All right, now find the probability that given a student likes technology, the student is a 10th grader. So this is conditional. Probability of being a 10th grader given the student likes tech. So earlier we've done our conditional probability formula where we have probability of 10th and tech over the probability of tech. But when we use a table, we can actually kind of skip a few steps here, and it's a little bit easier. So the probability of being a 10th grader, or the number of 10th graders, is just going to go on top who like tech, and the number of people who like tech will go on bottom. So starting with the denominator is how many people like tech. So out of all these different choices, we have 136 kids who said they like tech. Now, just looking at the ones who like tech, how many of them are 10th graders? Well, let's go ahead and look at technology. Where does it meet up with being in 10th grade? That's 23. So for the probability of 10th grade given technology, we get 23 over 136. C, find the probability that a student likes foods or PE. And for part B, if you were to go through the whole formula and everything, it works out the same exact way. All right, so C, find the probability that a student likes foods or PE. Okay, liking foods and PE. These are two mutually exclusive, oops, that was too big. So liking foods and liking PE are mutually exclusive events. So we can just add their probabilities. So we're going to find the probability you like foods, which is how many people like foods? 177 out of 537, plus the probability you like PE, which is equal to 131 over 537. And we add them up. We get 308 over 537. 308 over 537 is the probability you like foods or you like PE. All right, and last, find the probability that a student likes fine arts, you like fine arts, given you're in 10th grade. All right, again, the probability or the number of people in 10th grade is going to go in the denominator. So how many people do we have that are just in 10th grade? Here's my 10th grade column, and we have 127 10th graders. So let's put 127 down here. And then the top comes from, out of those 10th graders, how many liked fine arts? So only looking at the 10th grade kids, what's the number of kids that liked fine arts? It's right here, 31. So we're going to put 31 up top. And there's our probability, 31 over 127. And that's it.